All right, so we're on 1-3 today, distance and midpoints. This is stuff you already know, you just haven't seen it for a while. So I'm not saying you should have it memorized necessarily, but I am saying you've seen it before. It's not new to you, okay? I think that kind of helps sometimes. So distance between 2 points, we've already done the distance between 2 points on a number line. We did that yesterday with our proofs. Remember? You took one minus the other with absolute value bars. We've already done that. Okay? The distance between 2 points on a coordinate plane, your xy plane, right, is x2 minus x1 squared plus y2 minus y1 squared, all under a square root sign. That's not new to you either. You probably memorized that last year. You maybe don't remember it now, but you've done it. Is that okay? Okay. So now we have the midpoint of a segment. Midpoint means what? Middle, right? Smack dab in the middle. So when it's on a number line, you just average them. You take one plus the other, divide by 2. That's an average, right? Same thing for a coordinate plane. You average the x's, x1 plus x2 over 2, and average the y's, y1 plus y2 over 2. Does that make sense? So for some people, the formula is helpful, but sometimes it's easy just to look at this. If this was a 2 and this was a 4, what's the midpoint of 2 and 4? 3, right? So sometimes you can just look at it and figure it out. But if I said 2 and 107.7, that would need a formula for sure. Does that make sense to you? Okay. All right, definition of midpoint. M is the midpoint of line segment PQ if and only if M is between P and Q. That's what that says. And PM is equal to MQ. So let's draw a picture. M is the midpoint of PQ. That would be in the middle, right? For it to be the midpoint, they have to be collinear. That's what this means. M is between P and Q. For it to be the midpoint, they have to be collinear. It's directly in the middle. If it's in the middle, then each of these pieces are the same. PM is technically congruent to MQ, right? And then we know it's in the middle. And then for midpoint theorem, if M is the midpoint of line segment PQ, then that must mean line segment PM is congruent to line segment MQ. That all is talking about that same picture that I have right there. Is that all right? It means it's in the middle. If it's in the middle, then those two pieces must be the same. Okay? Definition of segment bisector. When you hear bi, what do you think? 2. So segment bisector cuts something into 2 congruent pieces, okay? So any segment line or plane that intersects a segment at its midpoint. That's the same thing I just said, but in a different way, right? So if it goes through its midpoint, it must cut it into 2 congruent pieces. That's the same thing. Does that make sense to you guys? And then you have a picture there to look at, okay? Okay. We will come back to this. It's the proof stuff, but the good news is if you aren't super confident in the proofs that we did yesterday, today's proofs, the first part of it is yesterday again, so it's like a built-in review for you, plus a little bit extra, okay? So if you still don't feel great about those proofs we did yesterday, it's going to be an automatic review for us, all right? So we'll come back to that in a second. Find the distance between m is at -3.8 and n is at -5.1 to the nearest tenth. So we're going to use what? The distance or the midpoint formula? What did they ask us for? Distance. So what formula am I going to use? Distance, right? So on that front page, am I going to do distance between 2 points on a number line? Or am I going to do distance between 2 points on a coordinate system? The coordinate system, right? Because these are 2 ordered pairs, so that's on the right side. Does that make sense? So until you have them memorized, if I were you, I would write down the formula every time and then substitute, okay? So our formula for the distance is the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. In my opinion, until you have them memorized, I would write that down, okay? The question now is, what's x2, what's x1? How do I know what those are? Give this a letter. That's an x, and that's a y. That's an x and a y. This is the first x I saw, so I'm going to call it x1. This is the first y, so I'm going to call it y1. This is the second x, x2, second y, y2. Easy? right? Does it matter? Could I have called this x1, y1, x2, y2? Yeah, you'll get the same answer either way. So it doesn't matter. Typically, the first one I see, I call x1. Okay? So I'm going to substitute. X2 minus x1 is going to be my negative 5 minus negative 3 squared. And I'll do that in a moment. And then y2 is my y, excuse me, my 1, excuse me, minus the 8 squared. Does everybody understand all I did was substitute? No big deal, right? From here, you are totally welcome to use a calculator in my class anytime you feel necessary. But like I said before, with the ICEP test coming up, some things you're allowed to have a calculator and some things you aren't. So I'm going to try to use my calculator as little as possible, but please know that you're welcome to use it anytime. I don't care. Okay? So order of operations, say parentheses come first. So this is not a proof. I can draw plus plus here if I want to. If that helps you, do it. So I'm going to say two negatives make a positive. That's easier for me. And then what is negative 5 plus 3? Negative 2, still squared, plus what's 1 minus 8? Negative 7, still squared. Everybody okay? Now we do our exponents. What is negative 2 squared? That's negative 2 times negative 2. Positive 4. Negative 7 squared, 49. And 4 plus 49 is 53. So technically, the exact answer is the square root of 53. However, they said round to the nearest tenth. They don't want the square root of 53, even though it's completely correct. So now you do have to get out a calculator, because even I don't know that, right? Get out your calculator that you bring with you every single day. Wink, wink. Take the square root of 53, round to the nearest tenth. That's one decimal, right? What do we get when we round to the nearest tenth? 7.3, okay? So the final perfect full credit answer is 7.3. Do you guys see those two squiggles I just drew? That means approximately. What that means is I rounded. Technically, this equal sign here is correct because I did not round that answer. I should use approximately. I'm never going to mark off if you give me an equal sign where you shouldn't have. I don't care. I'm just teaching you the proper way. Okay? Did I lose anybody? Anybody still confused? Anybody still need this page? Excellent. Find the midpoint of line segment DE. D is at negative 15.4 and E is at 2, negative 10. I want you guys to go to the front of your notes really quickly. I'll stay here, you go to the front. What did they ask us for? Distance or midpoint? Midpoint, so go to those two options. What did they ask us for? On a number line or on a coordinate system? Coordinate system, so we're going to use that formula. Does everybody see it? Okay, so again, I write it down. You can come back with me. I write the formula down every single time until I have it memorized. The midpoint of two ordered pairs is you average the x's, x1 plus x2 over 2, and you average the y's, y1 plus y2 over 2. In my opinion, until you have it memorized, it's kind of nice to have that. Okay? What am I going to call negative 15? x1. What about the 4? y1. The 2? x2. And the negative 10? y2. So I'm just going to substitute. Again, I'm going to average the x's, average the y's. So I'm going to take negative 15 plus 2 over 2, comma, what? I'm going to say 4 plus negative 10 just for 2 seconds because that's what the problem says to do. But if you had written 4 minus 10, that's totally fine as well, right? Okay, so what is negative 15 plus 2? Negative 13 over 2. I'm going to keep that way for a moment. Okay, I only do one thing at a time. And 4 plus negative 10 is negative 6 over 2. In any math class, what do you always do with a fraction if possible? Reduce it, simplify, whatever you want to call it. So I'm not graphing this, so I don't care. I can leave the negative 13 over 2. That's fine. If you want to change it to negative 6.5, that's fine too. But since I'm not graphing it, I don't really care how it's written. So I'm going to leave it negative 13 over 2. However, negative 6 over 2, I have to change to what? Negative 3, right? You always reduce a fraction. Would I mark it wrong if you had negative 6.5? No, it's the same thing. I don't care. I just don't do extra if I don't have to. Okay? Did I lose anybody? All right. Anyone still need that page? Excellent. Find the coordinate of the missing endpoint if B is the midpoint of line segment AC. A is at -4, 2, B is at 6, -1. Okay? So technically, I don't have to graph this. I want you guys to watch me for just 2 seconds, but I want you to know you don't have to do this unless you really, really want to. So I'm going to graph it just because, but you don't have to. Okay? So I'm going to go 2, 3, 4, 5, 6. If I do -4, 2, that's left 4 and up 2, label it. If I do 6, -1, 4, 5, 6 here, okay? It says find the coordinate of the missing endpoint if B is the midpoint. So what that means is, I'm going to put an M there so I know it's the midpoint. I need to find the missing endpoint. So it's probably over off my screen somewhere, right? If B is the midpoint, then this is the endpoint to the left, so I'm missing the endpoint somewhere over to the right. Does that make sense? Hang on just 1 second. You could do that. That's a bit harder than what we're going to do, though. Okay? So it's not wrong. It would get you there, but let's get there faster. I didn't have to graph that. I just kind of wanted you to see it, okay? So what I'm going to do is I'm just going to draw it as if it was on a number line, even though that's not right at all, right? They said B is the midpoint, so I'm going to put that here. A is an endpoint, and C is another one, right? B was at 6, -1. A was at -4, 2. Where's C? What am I going to call that? X, Y. Very good. Okay, so this is not on a number line. This isn't actually right, but I don't want to think of it this way because I don't really get that because I'm missing something and I don't know where it is. Do you guys get what I'm saying? Okay, so you can graph it if you want to. I just don't think it's super helpful. I just did this instead. So we're going to do, again, midpoint formula. It's the same as the one we just did, but this time we're missing one of these, right? This one, we were looking for the midpoint. On this example, they gave us the midpoint. It's the exact same formula. It's the exact same concept. We're just missing a different piece of the puzzle. Does that make sense? So I'm going to write the formula again. Maybe. There we go. I'm going to say midpoint equals average the x's, average the y's. It is the same formula. Is that okay? Okay, what is the midpoint again? Where's that one at? 6, -1, sorry. All right, so the midpoint is at 6, -1, okay? So I'm not going to use B anymore. That was my midpoint. That's done. Does that make sense? My endpoints are this one and this one. Do you guys get that? So you average the x's, average the y's. I'm going to take -4 plus x, right, over 2, comma, 2 plus y over 2. Do you guys understand this is the exact same thing we just did? We're just missing a different piece. Is that kind of okay? Okay. Here's where you're probably stuck. All right. What's this letter here? X. What's these? X. What's this one? Y. Y. With an equal sign in between them. So aren't the x's still equal and aren't the y's still equal? Right? So I'm going to set the x's equal to each other. I'm going to set the y's equal to each other separately. I'm going to make 2 separate equations. Okay? I'm just going to pull them apart. So 6 equals -4 plus x over 2, and -1 equals 2 plus y over 2. Do you guys understand what I did? I put the x's together, and I put the y's together. From here, it's decent algebra 1. Great? All right, so on this left side, what do I have to do? Very good. We're dividing by 2, that's in the way. So how do you undo dividing by 2? Multiply by 2. So if I multiply this side by 2, it goes away. That was the point. But if I do it to one side, I have to do it to the other side, or else it's not equal anymore, right? What you do to one side, you do to the other, okay? So I get 12 equals negative 4 plus x. What do I do to both sides now? You add the 4, so x is 16. Is that okay? Okay. Same thing here. Multiply by that 2, so it goes away. What I do to one side, I have to do to the other. So I get negative 2 equals 2 plus y. What do I do to both sides to get the y alone? Subtract 2, we end up with negative 4. So my ordered pair is 16, negative 4. That's what they were looking for. It's the same thing as the one before it, just missing a different piece. No. What's just 2 times 1? Right? Okay. Everybody good? Anyone still need that page? Are you okay? Okay. All right, I'll go back if you need me to. Let me know later. Suppose M is the midpoint of line segment FG. Find FG. The first thing I'm going to do is tell myself they're looking for FG. If I don't do that, I accidentally forget and I move on and whoopsie. Okay? If there's no picture, draw a picture. Okay? So M is the midpoint of line segment FG. They said it was the midpoint. They did not say it was in between. So that's a very specific example. It's smack dab in the middle. Do you see those tick marks? That indicates it's smack dab in the middle. Okay? So I'm going to label what I know. I know FM is 3x minus 4. And I know MG is 5x minus 26. I'm just labeling what they said. That's a minus 26, sorry. Even though they want FG, what do I really have to look for first? Yeah, you have to find X first, don't you? They didn't ask you to, but there's really no other way to do it, okay? So don't say anything out loud just yet. Take a moment and look at that and see what you think we would do to find X. What do you think? If we added them together, what would we set them equal to? Okay, so you're not wrong. If they had given us like the whole thing was 24 or something, we would have done that, but we didn't have anything there, so that didn't help us on this question. What you said would have helped us on this question. Isn't this piece the same as this piece? What's that mean? They're equal to each other, right? So 3x minus 4 is equal to 5x minus 26. Like I told you yesterday, in geometry, typically the first step or two is geometry. After that, it's easy algebra 1. Okay? I want you guys to try to find x on your own, because there's 4 different ways to finish this problem. I want you to pick a way that works for you. So try to find x, lean to a neighbor, see if they got the same as you. What'd you guys get? You should get 11. I'm going to do it anyway, okay? Eventually in this class, I don't do it unless you ask me to, but for like a week or two, I assume maybe you're too embarrassed to ask a question, so I'm just going to do it anyway, okay? I work with the variable first. I keep it positive. That's how I start these. So I'm going to get the 5x and the 3x together. So I'm going to subtract the 3x over, so that way it's a positive, okay? I'm left with negative 4 equals 2x minus 26. What do I have to do to both sides now? I would add the 26. So it's 26 minus 4. 22 equals 2x. What do I have to do now? Divide by 2. X is 11. That's not what they wanted. What did they want? FG. FG is the whole thing. What are we going to do? Okay, you're all right. You can plug it, you can substitute. You can substitute x as an 11. You could do it here and here, and then do what with them? Add. You could do it here only and do what with it? Double it times 2. You can do it here only, double it. You pick whatever you want. I'm going to put it in here and double it. Okay? So 3x minus 4, right? Because they're supposed to be the same, right? So whatever I get here, it's actually the same as here. I don't have to check it. If this were a test and a quiz and I had time, I would check it. I would have plugged it into both and made sure I got like 7 and 7. But on a homework assignment, I'd plug it into one and double. But you do whatever you want to do. It's not like it takes that much longer. Okay? So that's 33 minus 4, which is 29. So for me, I just said this piece was 29. How do I find the whole thing? 29 plus 29, 29 times 2, however you want to do that, right? And what do we end up getting for FG? Say it again? I heard 3 different answers. 58. Okay, it's all right. So let's just, because, plug it in over here. What's 5 times 11? 55 minus 26. 29. So they're the same, and they better be, right? And then 29 plus 29 if you want to do it that way. Okay? So don't get used to algebra 1 where you found x, you circle it, you move on. That's not actually what we were supposed to do here, right? We had to finish it. Okay? Did I lose anybody before we go to proofs? Baby proofs. Are you sure? Okay. Was that pretty easy for you? Right? All right. We're going to do the same thing we did yesterday, plus a little bit more. So before we can even do it, let's go ahead and label all of these. What are these split into? Thirds, fourths, fifths? Fourths. If you look here, like if I start at the 0, there's 1, 2, 3, 4. This is split into fourths. Okay? So where's D at? Let's just start there. 1/4. Where's E? 2. Where's F? 2 and 3/4. You guys try A, B, and C. You label A, B, and C. You have a pencil with an eraser. If you get it wrong, no big deal. We'll erase it. That's a good question. She asked if it's 2/4, do you want to put 1/2? In math, you always reduce. I would put 1/2, even though mathematically, when we get to subtracting them without a calculator, it would be easier in our heads for the 2/4. You really should reduce every time. So I would do 1/2. Okay. So where's the C? -1. Where's the B? -1 and 1/2. Maybe -1 1/2. And where's the A? -2 and 1/4. Excellent. Just like yesterday, except for it was fourths instead of whatever we had thirds, right? Okay, so show that D is the midpoint of line segment BE. Yesterday, they said show that D is between B and E, right? Today it says midpoint. So what that means is we have to do everything we did yesterday, because if we go back to what it means to be a midpoint, you don't have to try with me if you don't want to, but to be a midpoint, first it has to be between the two letters, okay? And they have to be equal lengths. All right, so you have to have both things. Here's why. If I just jumped to those two pieces being the same, so they want D is the midpoint of BE. If I just said BD is equal to DE, right, that doesn't necessarily mean it's the midpoint. Here's why. If I did it here and I just said, hey, PM is the same as MQ, and I never proved that it was in between them, if you look at this, PM, let's say it's 2 inches, MQ, let's say it's 2 inches. These are the same, but is M the midpoint? No. So you have two parts to it. You have to first say it's in the middle. You have to say it's in between them. And then you have to say, oh, by the way, they're equal spaces. So it had to have been in the middle. Okay? So if you look here with me, this is never for you to understand right now. It's for once we do a problem and you go back to it and you're like, what was step 1 again? Then you'll read it and it'll make more sense to you. So step 1 is we do everything we did yesterday. That's what we did yesterday. After that, you do part 2 of the definition of midpoint, and I'll show you how to do that. And then we'll come back and it'll make more sense. Okay? So let's actually do the proof. Step 1, do everything you did yesterday. Okay? If I ignore this up here and I say D is between B and E, if I just do that, D is between B and E, just like yesterday. It is, but we don't know it yet. We haven't shown it yet. So you can put it wherever you want for part 1, but because I know our goal eventually is the midpoint, I'm putting it in the middle. Okay? That doesn't matter because that's not actually part of the proof. It's just us writing it down. Okay? So yesterday we would have said BD plus what? DE equals BE. That's exactly what we did yesterday. We're going to do it again. Is everybody okay with that? Okay? And if you remember, our formula to find the length between two numbers on a number line is something minus something absolute valued every time, plus something minus something absolute valued equals something minus something absolute valued. That's the formula to find the distance, just like yesterday. Okay? So where is B located again? -1.5. I'll fill that in. Where's D? I think positive 1/4. Okay. And then D again, 1/4. Where's E? 2. You guys try this one. You guys try to fill in the BE part. Okay. That's a good question. As long as you're not rounding, it technically doesn't matter. If you would want to change these, none of these would be rounded. So if you would want to change that to like 2.75, that's technically not wrong. But eventually we'll have fractions that don't turn into pretty decimals, and I don't know that I would do that if I were you. So that's a good question. Even though I said you have to do everything I say how I say it, that's one thing that would be okay. If you have 0.25 and I have 1/4, that's fine. If you have 0.3 and I have 1/4, that's not okay because it's obviously not the same. Okay? So for now, since we're doing it this way, maybe do fractions with me, but if you want to try decimals on your own, that's fine too. Okay? Like yesterday we had the thirds. 1/3 you can't do, right? 0.3 repeating we can't really work with, so I would have kept that one a fraction. Does that make sense? Okay. What'd you guys get for the BE? What's B? -1.5 minus, where's the E? Just the 2, right? With a minus sign already there. So now we actually do the subtraction. Get out your calculator, please. We can do this without a calculator, but I want to show you a calculator today since I didn't show you that yesterday. Okay? And I know you guys know -1.5 is -1.5, and that's easier to put in, but eventually that's not the case. I want you to learn how to do a fraction on your calculator. So, -1 and 1/2. Most of you have the same calculator, but I don't actually see any in here today. Hold up your calculators. That one. His. the guy that I don't know his last name. Him. Alex. Yes? Perfect. So most of you have that one. I'll help you, and everybody else, give me a moment, okay? I'll help you in a second, too. A lot of you have the same buttons, they're just not in the same place. So to do -1.5, most of you do the negative first, which is not the minus sign, right? You do the negative first, 1, ABC button, find your ABC button, 1 again, ABC button, 2. And if you look at it, it should look like -1 and 1/2, right? And then do the -1/4. So 1 ABC 4. Okay. What do you get when you do that? Yeah. Right? If you followed me and you understood that, go ahead and finish it with your calculator here. If not, I'm going to walk around and help you guys with your buttons because you're all a little bit different. Okay? If you don't have a calculator, do it without one. You can still do it. Right? It's doable. And yours is backwards. You have to do the negative like here. But you have the same button. So 1 and 1. Yeah, everybody else does too. I'm pretty sure you have to do negative box up here. You can try not to. That's the yours is backwards. Right? These were 4, 4. Okay. Try -1.5 minus. So that's what that's But you with a calculator that you don't know what's happening. calculator is still like, I'm not quite comfortable yet, we'll keep working with it, and I'll do what I just did. I'll try to walk around. If you have a question, let me know. Make sure you're bringing your calculator so I can help you. All right, so what do we get for this set of absolute values? Negative 1 3/4. What do we get for this set? Negative 3 1/2. And then we get rid of the absolute values, right? So this is positive 1 3/4 plus positive 1 3/4 equals positive 3 1/2, right? What's 1 3/4 plus 1 3/4? 3 1/2 equals 3 1/2. Is that true? So what we've just proven is that D, excuse me. We've proven that D is between B and E, like yesterday. That's not what they actually asked us to do yet, right? We've done half of it. We've proven it's in between them. Now we need to prove that those two pieces are the same, okay? So part 2 is new. Part 2, we need to prove that BD equals DE. If we look at our picture, I need to prove that this piece is the same as that piece. Do you guys see what I'm saying? Okay. So we're going to do everything we just did. This literally says find the length of BD. Okay? So it's going to be something minus something, because that's how we do the distance formula on a number line. It's going to be something minus something, right? Where is B located? I'm not going to scroll up. You guys look at yours. Negative 1 1/2. Good. Where's D located? 1/4. And then D again. 1/4. And where's E? 2. Do you guys see how I'm filling that in? Okay. What's negative 1 1/2 minus 1/4? Negative 1 3/4. What's 1/4 minus 2? Negative 1 3/4. Absolute values, I get 1 3/4 equals 1 3/4. Is that true? Therefore, D is the midpoint of BE. If I'm going to show you two different ways. I'm going to show you how to think about it, and I'm going to show you back in the directions. Okay? So part 1 is where you prove it's in between them. Part 2 is where you prove that they're the same. If it's the midpoint, when I go back up to my picture, it means these had to be the same. So I just went left to right. BD is the same as DE. Okay, I'll come back here, but let me show you how we knew to do that. So part 2, state part 2 of definition of midpoint with corresponding points. That means, right here. That means that. That's what I just did. Okay? All right, I'm going to go back here because I assume some of you still need to write it down. Again, am I asking if you can do it on your own yet? No. Am I asking if you can kind of follow me as I do it? Yeah. Right? Mm-hmm.
So, the reason, just want to clarify.
Sure.
So, is the reason why we just part 1 just to figure out if D is?
Yes, because if we don't do part 1, if we just did part 2,
Yeah.
that doesn't necessarily mean it's the midpoint. That's the example I was showing you before. It could just mean that both of these are 2 inches, but it's not necessarily a midpoint because they're not attached. Do you see what I'm saying? So we have to do both parts. Okay? Okay. Does anybody have a question anywhere? Are you sure? Okay. Well, here's our